Let's take a look at acids. Here are some properties of acids. Acids have a sour taste. They react with certain metals such as aluminum, zinc, and iron, but not copper, silver, or gold. And when acids react with a metal, in this case aluminum, they make an ionic compound, in this case aluminum chloride, and give off hydrogen. And this is actually a redox reaction. We see we have an element that is reacting and a different element that is formed. Acids are known as corrosive because they do react readily. They react with carbonates. Carbonates are what are found in baking soda, chalk, limestone, and marble. And if you've ever added vinegar, which is an acid, to baking soda, you see a gas is produced, and that gas is carbon dioxide, which comes from the carbonate. Acids will also change the color of vegetable dyes, which is how litmus paper works. And all acids will react with bases to form ionic compounds. Here are some common acids. Nitric acid, HNO3, is used in explosives, fertilizers, dyes, and glues, as is sulfuric acid. Sulfuric acid, H2SO4, is the acid that is found in car batteries. Hydrochloric acid is used in metal cleaning, a small amount in food preparation or refining. It's the acid that is in your stomach. Phosphoric acid is used as fertilizers to make plastics and rubber, and it's also a food preservative. Acetic acid is the acid that's found in vinegar. It's used to make plastics and rubber. It's also used as a food preservative, for example, to make pickles. Hydrofluoric acid is used for etching glass and cleaning metal. Carbonic acid is known as soda water, and boric acid is known as is used for an eye wash. And carbonic acid, by the way, is very unstable, and it will decompose into water and carbon dioxide gas. All acids have a hydrogen, and this hydrogen dissociates or comes apart when it's dissolved in water to form an H+. There are acids that are known as binary acids that contain hydrogen and another element. HCl is a binary acid. This is hydrochloric acid. HF is a binary acid, hydrofluoric acid. Acids can also be formed from hydrogen and then oxy-polyatomic ions. These are known as oxyacids. So sulfuric acid, nitric acid are examples of these oxy acids. And then the hydrogen is always attached to an oxygen. If we cover up the hydrogen, we should notice that SO4 is sulfate, and if we cover up the hydrogen there, we should notice that NO3 is nitrate. Another type of acid known as a carboxylic acid. These are organic acids, and they're a type of acids that are found naturally occurring in nature, such as citric acid or absorbic acid, as well as vinegar, which is a naturally occurring acid. These have what is called this Cu group, and it's a carbon with a double bonded oxygen and an OH, and it is this H here that is acidic, not the other H's that are part of the other part of the molecule. So this carboxylic acid group, or this Cu group, is found in citric acid, malic acid, and any other naturally occurring acid. Now let's look at bases. Bases are also known as alkalis, and they have a bitter taste. If you've ever tasted soap, then you know that it has a bitter taste. Alkalines, or these bases, can be poisonous. Definitely not. Most of our food is in the acidic range. Just a few foods are in the basic range. Basic solutions feel slippery. So if you've ever gotten some ammonia or bleach on your hand or even soap, that slippery feel is due to the fact that those solutions are basic. Bases, like acids, can also change the color of vegetable dyes, which is again how litmus works. And bases will react with acids to form ionic compounds, and this process is known as neutralization. There are some common bases. Sodium hydroxide is also known as lye or caustic soda. It is typically the main ingredient in drain cleaners. It's used to make soap, plastic. Potassium hydroxide is also known as caustic potash. It's also made in soap. It's used to refine cotton. It's used in electroplating. And it's a strong base like sodium hydroxide. It can also be used to clear out drains, which basically occurs by dissolving things such as hair and fats. Calcium hydroxide is also known as slaked lime. It's used in making cement. Sodium bicarbonate, also known as baking soda, is used in cooking. It's also used as an antacid because as a base, it will react with the hydrochloric acid in your stomach. Milk of magnesia, another antacid, which will react with the acid in your stomach. And then ammonia, ammonium hydroxide, which we know as ammonia water, is used in detergents. It's used as a fertilizer. It's used as a cleaner. And these are just some examples of some common bases in our everyday life. Bases are either going to contain the OH ion, such as sodium hydroxide, or they're going to cause the formation of hydroxide in water, which is what carbonate and bicarbonate do. And then many of the organic or naturally occurring bases, such as caffeine, have a nitrogen in them.